Morning, everyone. Sorry if you can hear some stuff in the background there. I don't know if my microphone can pick it up. Looking at my microphone levels, it looks like you can probably hear it. They're cutting down trees next to my house. I don't really know why, but that's what they're doing. So let's see here. I don't think there's really anything I need to talk about. Did a lot of those housekeeping items yesterday. I've received a few of your sort of bonus assignments. Let's see. One student has asked if you need to submit your radicals assignment. I'm just going to reply now. There is no radicals assignment yet. The radicals homework is just practice. Okay. Let's see here. I don't think there was really any other questions. I think one student asked about a PDF versus JPEGs. I want a PDF. So if you need help making a PDF, I would suggest looking on YouTube or Google or something. The easiest way that I know how to do it is to use Microsoft Word. Just put all the JPEGs into a Word document and then save your Word document as a PDF. I think that's probably the best way to do it. Oh, look who came to say hello. Hey, sweetie. So we're going to, and now she's just right on top of my iPad. Yep. She does not want us to do any work today. Oh yeah, there's, I guess I'll point out one thing. On the website, there is a form, and I think I talked about the form a little bit yesterday, but it's online now. So I'd really like it if you could fill out that form. Hey, sweetie pie. Yeah, so on the form we have, oh, she's typing stuff to you. Look at that. She's just laid back on the keyboard. So yeah, on the form, it's just a feedback form. So please take a minute or two to fill that out. It would really go a long way if I got a little bit of feedback, just hearing from you about what's working, what's not working, that kind of thing. So it's right on the homepage of the website. You can't miss it. Go to mathbennett.com and it's right there. So yeah, please take a look at that. And aside from that, I think that's it. So we can get started now. And I'll have to kick Goose off of my desk because she really wants to play right now. This morning she ate a cucumber and puked it up because that's how cute she is. She pukes up cucumbers. Okay, so yeah, we're going to talk about radical equations today. We're going to sort of continue where we left off yesterday. So yesterday we were talking a little bit about some of the restrictions. What's on Google Classroom? The bonus assignment? Yeah, it is on Google Classroom right now. So if you need if you can't open it, let me know and I'll try to troubleshoot that, but I'm not going to do it right this minute. From the website. Oh no, the form, the feedback form is on the website. The bonus assignment is on Google Classroom. Okay. Okay, so it's time for you to go. Even though I want to just play with you all day. Okay, maybe I can do both at the same time. We'll see how that goes. Okay, let's see here. So yesterday, yeah, like I said, yesterday we were looking at some of the restrictions that can be placed on radical equations and expressions. We're gonna sort of expand that a little bit more today. So let's try to solve this equation. So let's solve Well, first of all, let's do something easy. Let's solve this one here. Let's say the square root of x is equal to 3. Okay? Let's say the square root of x is equal to 3. So what would we do here? Well, one way to get rid of that square root symbol is to square it, right? So why don't we square both sides? That's an operation that we can perform. So if these two things are equal, then their squares must be equal. So the square root of x squared is equal to 3 squared, or in other words, x is equal to 9. So that's the basic operation that we'll be doing, is squaring both sides of the equation. Okay, she's getting really up in my face right now. Might have to change some stuff. Okay, time to go. Yeah, look at those cool people cutting down the trees. Go play with them. Okay, sorry, I'm a little distracted right now. It won't let me open it from the website. Oh, okay. Should be okay to open on the website. I thought that it would work. Let me just quickly double check here. Yeah, I mean, it seems to be working on my computer. I'm not really sure what's wrong. I'll look into it a little bit later. But yeah, I'll do my best. Yeah, it looks like the survey worked for some students. Anyway, yeah, if you have difficulty filling it out, let me know. But I'm not gonna troubleshoot that right this minute. Okay, let's solve another question. Let's solve this one. Let's solve. Oh, and by the way, let's just double check that this works. So let's check. So we're gonna actually have to do this for every question. I know it sounds maybe a little bit crazy, but what happens is sometimes when you do this squaring business, what sometimes happens, and it's especially true if there's variables on both sides of the equation. What happens is sometimes if you get a negative that gets sort of canceled out, you get a solution that doesn't work. So we actually do have to check every single question here and just double check that our solution is correct. And it turns out that the square root of 9 is indeed equal to 3, so we're good. So our solution is 3. Our systems have detected unusual traffic. Weird. I'll look into that, but I don't think I'll do that right now. Okay, let's solve another one. Let's see. I had one right up here. Where was it? Aha, here it is. Okay, so let's solve. Let's solve this one here. So I've got the square root of x plus 1 equals x minus 1. Okay. So we're looking to solve for x. So first of all, let's talk about the restrictions. So the restrictions are the following. So we need that the radicand here, that needs to be greater than or equal to 0. So x plus 1 must be greater than or equal to 0. Or in other words, x must be greater than or equal to negative 1. So any value of x that's less than negative 1 cannot be a proper solution. It does not work. So let's go ahead and start solving this. So let's actually solve it. So I'll just write the whole thing out again. So the square root of x plus 1 equals x minus 1. And what we'll do is we'll square both sides. Now it's important that we actually square the entire expression on both sides of the equation. You can't just like put some square symbols and be done with it. That's not how it works. We're going to square the entire side of the equation. So I'm going to, just to be very clear about what I'm doing, I'm going to put brackets around both sides of the equation and square that. And I'll put brackets around here. I'm going to square that. And let's follow through that. So that the square root of x plus 1 squared is just x plus 1. Okay, so because I take x plus 1, take the square root of it, and then square it back. It doesn't matter really like what's going on here. Like we know based on the restrictions on x, we know that we're not going to get some negative value here. This is going to be greater than or equal to 0 based on the restrictions that we have on x. So we are allowed to do that. Furthermore, like what I'm saying is we don't have to worry about absolute values or anything like that. Furthermore, let's square the other side. So I'm going to have x squared minus 2x plus 1 over here. And now I have to solve this. And this is some kind of quadratic equation. Let's see here. So here's a nice quadratic equation. And I'm going to set it equal to 0. That way I can actually go about solving it. So this gives me x squared, or it's a minus 3x, x squared minus 3x plus 0, right? So that's what I get on that side. So I can factor this. I can say that 0 is equal to x times x minus 3. Right, I'm just factoring that out. So in other words, x equals 0 or x equals 3. Those are my two possibilities. Now we have to double check that it works in the original equation. So we need to check. So we need to check our solutions in the original equation. So let's go and do that. So I've got the square root of, well, let's try this first one. Let's try, okay, just to be very clear, I'll try check x equals 0. So I've got the square root of 0 plus 1 is equal to 0 minus 1. Well, the square root of 1 is equal to 1. And the square, or 0 minus 1 is negative 1. So these are not equal. What just happened? I am not sure what just happened. Okay, so we checked that one. Next up, we're going to check, and I'll do this in a different color. How did I get the 3x? Where did the 3x come from? Well, I'm setting this side equal to 0. By the way, I think there is an extra long delay here. I'm just going to type that. Sorry, there is an extra long delay today. Stay tuned for my answer to your question. Okay, anyways, so to answer your question, where did the 3 come from? So I'm setting the left-hand side equal to 0. That way I can solve the quadratic, right? So to solve a quadratic, what you do is you factor it, or sorry, you set it equal to 0 and then you factor it, right? And you use that factor theorem that one of the factors has to be equal to 0. So that x goes onto that side, so I subtracted x from both sides and I subtracted 1 from both sides. So negative 2x minus x is negative 3x. And 1 minus 1 is 0, so I get x squared minus 3x plus 0. I hope that answers your question. Okay, going back to the check, let's check our answer, our second answer. By the way, this means, so I'll write thus, x equals 0 is an extraneous solution. In other words, it's not a solution. It's not a solution at all. X equals 0 does not work, right? The whole point of solving an equation, doesn't matter what kind of equation it is to find values of the variables that make the equation true. X equals 0 does not do that. It does not do that. And the reason why this happens is because we're taking a square, and squares allow for like a plus and minus symbol. So because we're taking the square root of something, sometimes that minus symbol gets kind of lost along the way. So we have to check our answers. We absolutely have to check our answers here. It's not an optional thing anymore. Right? Like when you first learn about like linear equations, you're encouraged to check your answer. But you know, most people don't, because they, you know, most people are lazy, right? I'm no exception. I'm pretty lazy. So with linear equations, most people don't even bother to check their answers. Most of the time you can sort of eyeball it and you can kind of tell when your answer is right. With quadratic equations, I always say it's like a really good idea to check your answer, because it's so easy to check your answer. You just kind of plug some values in and then you're absolutely sure of it. With radical equations, it's no longer optional. You have to check your answers. Like you don't get a choice here. You have to check your answer, because you could do everything right, you could do all the right steps, and you will still be left with some solutions that are extraneous. And that's just how it works. You don't really have a choice. Okay, going back to the other check, let's check x equals 3. So what we'll do is we'll plug it into our original equation. So I've got 3 plus 1, square root of that, equals 3 minus 1. Let's see if that works. So square root of 3 plus 1 is the square root of 4, which is 2. And 3 minus 1 is 2. So yes, this works. So x equals 3 is a solution. In fact, it is the only solution. It's the only solution that works. Okay. Okay, let's try another one. Let's do another one. And if you have any questions, like I said, there's a very long delay today. I think it's like over 30 seconds. When you stream live on YouTube, you have the option to choose normal latency, low latency, and ultra low latency. I usually go ultra low, but when I started the stream today, I forgot to check off that box. So it's normal latency, which is quite long, which means that when the video is archived, it'll be higher quality, and there will be subtitles and things like that. Whatever. So there's just a bit of a delay. So if you have a question and you type it, I might just type it back, because it's quite a long delay. So sorry about that. Okay, so that was what we did over here. Let's try this equation here. Let's solve this one here. Okay, so solve. Let's solve. Let's see. Okay, so we're going to do the square root of 3 minus 3x. 3 minus 3x. We do the square root of 3 minus 3x, and that's going to be equal to 3 plus the square root of 3x plus 2. Okay, that's what we're going to solve today, or right now. So first of all, let's talk about the restrictions. Restrictions. Okay. So here we have two radicals, so we're going to have two restrictions. So this has to be greater than or equal to 0, and this has to be greater than or equal to 0. So let's consider that. So I know that 3 minus 3x must be greater than or equal to 0. And so let's just deal with that one first. Now I'm glad that we're going to talk about this one. So I have to do something on the side here. So I'm going to make a quick little aside. Okay, so the aside is the following. So when we're solving for inequalities, there's a parallel between solving inequalities and solving equations. An inequality, by the way, that's when you're solving some like kind of less than or equal to, or greater than, or greater than or equal to, or less than or equal to, or less than, you know, one of those. When you're solving those, you do almost all the same things that you would normally do with an equation, but there are some extra rules that you have to be aware of, particularly when you're dealing with negatives. So consider, if I have something like this, if I had like negative x equals negative 3, well, what I would do is I would multiply both sides of the equation by negative 1, and I wouldn't have to think twice about it. I would just say, okay, well, negative x times negative 1 is x. Negative 3 times negative 1 is 3, so x is equal to 3. So that's great. It's a little bit different with inequalities. Okay? So if I have that negative x is less than negative 3, well, let's think about what that means. So, well, okay, what I'm going to do, I'm just going to tell you what we do. So if we multiply both sides of this inequality by negative 1, we're not going to have that x is less than 3. We have to switch the inequality sign, and I'll show you why. So I'll just write, we switched the inequality sign. So we switch the inequality sign, and the reason we do that is, well, let's just try it with a few numbers. So like, let's say that x, let's find a number that actually works here. Let's say that x is 5, and that would work, right? Because negative 5 is less than negative 3, right? That's a fact. Negative 5 is less than negative 3. If I multiply both of these numbers by negative 1, I do not get that 5 is less than 3. It's not true. It's not true. 5 is greater than 3. So we have to actually switch the sign there. So that's the one. Well, there's a few other sort of funny rules with inequalities, but that's the one that we have to worry about today. So let's solve this inequality, and keep in mind that we may have to multiply both sides of this inequality by negative 1, in which case we'll have to switch that inequality sign around. So it's just going to point in the other direction. So let's do that. So I'm going to add negative 3 to both sides, or subtract 3 from both sides. So I get negative 3x is greater than or equal to negative 3. And I'm going to multiply both sides of the equation by negative 1/3. Okay? And because I multiplied by a negative, I have to switch the inequality sign. So I get x is less than or equal to 1. And let's just try this just to double check. So I think an easy example would be if x is 0, right? Because 0 is less than or equal to negative 1. So let's just say, for example, maybe x is equal to 0, right? Because 0 is less than or equal to 1, right? So if x is 0, then we would have 3 minus 3 times 0, which is actually just 0. So we would have 3 minus 0 is greater than or equal to 0. Yeah, 3 is greater than 0. So you can see that it actually does work. Okay, let's look at the other restriction now. So I've got 3x plus 2 must be greater than or equal to 0. So I've got 3x plus 2 must be greater than or equal to 0. Okay, so that means 3x must be greater than or equal to negative 2, and I'm just going to change that line so everything's kind of nice and organized here. There we go. And then I'm going to divide both sides by 3, so x must be greater than or equal to negative 2/3. Okay, so it looks like we have some bounds. Okay, so let's keep in mind we have to have both of these satisfied. So I'm going to write both need to be satisfied. Okay, so we have x is less than or equal to 1, and x is greater than or equal to negative 2/3. Okay, so let's draw this on a number line. Okay, so here's my number line. Here's 0, and here is 1, and here is negative 2/3. So if that is 1, I'm just trying to eyeball it so it looks a little bit nice. Let's say that this is negative 2/3. Okay, so x must be less than negative 1. So x must be less than negative 1 or equal to. So we've got all of these. So all of these numbers would be okay. And x must be greater than or equal to negative 2/3. So that means that we have these values. So if both of these are satisfied, the only way that we can have both of these satisfied is if x is somewhere in this range. So here the only values that we have, so the restrictions, the final restrictions are, that x must be I'm going to write the interval. I'm going to use interval notation. So x must be in the interval -2/3, comma 1. And I'm using square brackets because they could be equal to those endpoints. That's fine. So I've got x must be in this interval -2/3 and 1. Okay, so those are the only values that x could possibly be equal to. So if somewhere along the way we solve for x and we get a value that's smaller than -2/3 or greater than 1, like maybe we solve for x and x ends up being equal to 7, then immediately we know that is not a valid answer, because it would require us to take the square root of a negative number at some point. So those are our restrictions. Okay, so that looks good. Now let's actually solve the equation. Okay, I'm gonna have to sort of make some room here. So I'm gonna have to copy this out again. So bear with me here. I'm just gonna copy this and copy. Where's copy? You see, there it is. Okay, and I'll just go over here. I'm gonna have to erase some of this stuff. Okay, that's better, and allow me to paste it. Come on, paste. There it is. Okay, so let's solve this now. Okay, so we're actually doing some algebra now. So, not gonna lie, these questions, they look tricky. But fear not, they're not as bad as you think. Okay, so the first thing we're gonna do is we're gonna square both sides of the equation. Okay, and I'm gonna do that because I have a radical all by itself. So here is a radical already isolated. Okay, so what we're looking for is we want to isolate at least one of the radicals. If we can isolate one radical, then we'll square both sides, and then that will have us in like basically we just want to get rid of the radicals best we can. Unfortunately, we can't do it all at once. We can't just get rid of all the radicals. This is going to take several steps, which is okay, but it's going to take some time. So first thing I'm going to do is I'm going to square both sides of the equation because I already have one isolated radical. So let's go ahead and do that. So I'm going to square both sides. So I'll write 3 minus 3x. Oops. 3x. And this is all squared. And then I have to square the entire other side. So I've got 3 plus the square root of 3x plus 2. And that's all squared as well. Okay. So the left-hand side, I just get rid of it completely. So, or I get rid of the radical sign completely, rather. So this gives me 3 minus 3x equals, look, she's sneaking up on me. Very sneaky goose. Never saw you coming. Very sneaky cat. Okay, and yeah, I love you too. And it might work well for you to actually write this one out. So expand those exponents just so you can see exactly what's going on. So I've got 3 plus square root of 3x plus 2 times itself. And then we'll use the distributive property. So I'll have 3 times 3. I'll have 3 times root 3x plus 2. And then over here I'll have root 3x plus 2 times 3. And then root 3x plus 2 times root 3x plus 2. Okay, so moving right along. This side, nothing's happening on this side. On this side, I've got, well, 3 times 3 is 9. 3 times root 3x plus 2 is just that. 3 times root 3x plus 2. And then I've got the same thing again, root 3x plus 2 times 3. So I'll write plus 3 times 3 times root 3x plus 2. Okay, looking good so far. And finally, I've got root 3x plus 2 times root 3x plus 2, which is 3x plus 2. Okay, let's clean that up a little bit and then move on. So I might have to zoom out a little bit. Okay, that's better. On this side, I've got 3 minus 3x. On the other side, well, I've got, let's think about like terms. I've got 9 plus 2. which is 11. I have 3x, so I've got 11 plus 3x plus, now I've got 3 root 3x plus 2 plus 3 root 3x plus 2. Those are the same thing, so I've got 2 of them, so we'll take that and multiply it by 2. Well, the coefficient is already 3, so I'm going to multiply that by 2. So 3 times 2 is 6. So I've got 6 times root 3x plus 2. Okay. So that looks okay. Now what I'm going to do is I'm going to try to isolate the radical one more time. Okay? So remember I've got a couple radicals here. And, hi sweetie. I've got another radical, but now I've only got the one radical. So you can see that by squaring that one radical, I had to square both sides, I eliminated one of the radicals. So now I've only got one radical left, which I can deal with. One radical is better than 2. So let's move everything that's not a radical onto the other side. So I'm going to move the 11 over here, and I'm going to move the 3x over here. So that gives me, 3 minus 11 is negative 8. So I've got negative 8. And negative 3x minus 3x is minus 6x. And this is all equal to the square root, 6 times the square root of 3x plus 2. Okay. So that looks good. I'm going to get rid of those red arrows. They're kind of bugging me. There we go. Okay. So we got 8 minus 6x equals 6 times root 3x plus 2. Now I'm going to square both sides. So I'll just add this line like this. So I've got that squared. Is that squared? Okay. So let's square the left-hand side here. So I'm going to have 64. And then 8 times 6 is 48. And I'll have 2 of those. So I'll have minus 9. No, I guess it would be plus 96x. And then 6x times 6x would be 36x squared. Okay, so that's what I get on the left. And on the right, I'm going to square this. So I'm going to have 36 times the square, not the square root, just times 3x plus 2. Okay, so that looks good. I'm going to start cleaning it up now. So I'll leave this side alone for now. I've got 64 plus 96x plus 36x squared is equal to, 36 times 3 is, what is that? Is it 108 or something? I think it's 108. Yeah, it's 108. 108x. And 36 times 2 is, what is that? 72. So we've got plus 72. Okay. Now, this is just a quadratic equation. Like, don't get me wrong, the numbers are big, but we can solve this. There's nothing wrong with this. So let's go ahead and solve this. So I think I've kind of run out of room here. So I am going to just copy this. So just bear with me here. So I'm just copying it out one more time. I've got 64 plus 96x plus 36x squared is equal to 108x plus 72. Okay, let's move everything over to the left-hand side. Okay, so I'm going to subtract 108x from both sides, and I'm also going to subtract 72 from both sides. So let's go ahead with that. So 96 minus 108, what's that? Minus 14? I think it's, so 4 plus 8. 4 plus 8 is 12. Okay, so it's minus 12, right? Yeah, minus 12. So I've got minus 12x, okay, and then 64 minus 72. So here we would have 6 plus 2 is 8. So this is going to be minus 8. So we've got minus 8 minus 12x minus 36x squared. That's all equal to 0. And that's plus 36x squared. And I'm going to write this in the correct order. This is driving me nuts. So this is going to be 36 x squared minus 12x minus 8 is all equal to 0. I think we could probably factor this, like factor out a common factor. So let's see if we can find a common factor. I think 4 goes into each of these terms, right? Yeah, 4 goes into 9, or sorry, 4 goes into 36 9 times. So I've got 9x squared. So I'll take out a 4. I've got 9x squared minus 3x minus 2 is equal to 0. And I'll multiply both sides by a quarter, which just eliminates this. That's what's so nice about setting an equation equal to 0, is not only can you factor out a common factor, but once you factor that common factor out, it's gone. You can just get rid of it. So this is now just equal to 9x squared minus 3x minus 2, because I multiplied both sides of the equation by a quarter. Like if you want, I can say this is times a quarter, this times a quarter, right? So this quarter cancels with that 4, right? And then that 0 times a quarter is just 0. So we still just have 0 over here. So now this doesn't look too hard to solve, right? So let's see if we can do that. So I'm going to multiply 9 times negative 2. That's equal to negative 18. And I want to think of factors of negative 18 whose sum is negative 3. So I'm thinking 6 and 3. So yeah, we would have negative 6 and positive 3, because when you multiply those together, you get negative 18. When you add them together, you would get negative 3. So I'm going to write this as 9x squared minus 6x plus 3x minus 2. Minus 2, right? Okay, so good thing that we have so much experience with quadratics. I think that's really important. So now let's factor this. So I think that the greatest common factor between 9 and 6 is 3. And they both have an x. So I've got 3x times x minus 2. And this is, I don't think I can factor anything out. So I'll just write a 1 times 3x minus 2. And I end up getting 3x plus 1 times x minus 2. Oh, and by the way, this is an equation. This is all equal to 0. Sorry about that. So now I have two solutions. There we are. There's my two solutions. One of my solutions is this one here. This would be that, because either of these have to equal to 0. So I've got x is equal to negative 1/3 or x is equal to 2. So those are my two possible solutions. Now let's see if any of those break our restrictions. So I've got negative 1/3 and 2. So negative 1/3 would be right around there, and 2 would be right around here. So negative 1/3 and 2. So 2 is not a possibility. Negative 1/3 is a possibility. Let's see if it works. So just to be very explicit, I'll write x equals 2 is not a solution because it does not satisfy our restriction. In particular, let's see where that comes from. If x were equal to 2, if x is equal to 2, and I'll write this in orange so you can see that it's new. So if x equals to 2, we would have the square root of 3 minus 6, which is equal to the square root of negative 3. Can't have it. Right there it is, right there. So x equals 2 cannot be a solution, even though we didn't break any laws of algebra. It just happens that as you do this algebra, at some point, just dealing with squares and negatives and things canceling out, you're going to get some solutions that are not valid. So this is an extraneous solution. I'm just going to abbreviate solution. Okay, so that's an extraneous solution. Let's try x equals negative 1/3. X equals negative 1/3. And where are we? I just want to find the original equation. Oh, I think I can paste it. Yeah, there it is. So let's try it in there. So let's do, the square root of 3 minus 3 times negative 1/3. And let's see if that's equal to 3 plus the square root of 3 times negative 1/3 plus 2. Okay, let's see what we get. In this first one, I have the square root of 3 minus, well, 3 times negative 1/3 is positive 1. So this is going to be 3 plus 1, which is 4. So I've got the square root of 4 is equal to 3 plus, so 3 times 1/3. 3 times 1/3, I'm starting to think that this is not going to be a solution. So 3 plus the square root of, okay, so that would be negative 1. Negative 1 plus 2, which is 1. And yeah, so I get 2 is equal to 4. Well, 2 is not equal to 4, so this is also an extraneous solution. So imagine that, after all that work, so x equals 2 is also an extraneous solution. So there is no solution. Wow, imagine that, eh? After all that work. Isn't it 3x minus 2? It's 3x minus 2. What am I writing here? 3x minus 2? Hold on a second. Did I make a mistake here? Yeah, I think I made a mistake. 3x minus 2. Yeah, this should be 3x minus 2. Okay, my bad. Let's see if that changes anything. So 3x minus 2. Yeah, okay, sorry about that. So this should be 3x minus 2. See, good thing you pointed it out, but I feel like that was like an hour ago that you said that, because the lag is so late. Okay, so let's try. So this would be, x would be equal to 2/3. 2/3, okay, and let's see if that, so 2/3 would be over there. So it actually does work with our restrictions. So let's change this a little bit. X equal to 2/3, rather, 2/3. It is a solution. It is a, well, actually we don't know if it's a valid solution. We still have to check it. So let's check, quickly check. X equals 2/3, right? It's 2/3, yeah. So let's try x equals 2/3, and I'll quickly paste it in here, and let's see what we get. So okay, so I've got the square root of 3 minus 3 times 2/3. And that's supposed to be equal to 3 plus the square root of 3 times 2/3 plus 2. Okay, so on the left here, 3 times 2/3 is just 2. They cancel out. The 3's cancel. So we've got 3 minus 2, which is 1. So this is the square root of 1. And that's supposed to be equal to 3 plus the square root of, well, these 3's cancel. I've got 2 plus 2, which is 4. So is 1 equal to 5? No, they are not equal. So x equals, so this x equals 2/3 is not a solution. Okay. So even though it's still fitted within the restrictions, the solution was not valid. It's not a valid solution. So so x equals, and and this was supposed to say 1/3. So x equals 1/3. So this is not a solution. It's extraneous. Yes. Okay, so this is an extraneous solution. So there's no solution. And I know that I've gone over by a few minutes here, so I have to apologize. But what I'd like to do really quick is just take a look at the graphs of these and just kind of show you what's going on behind the scenes. So let me just put my iPad upside down. Oh, I wonder if I messed up the... Is everything upside down? No, it's not. It's good. Okay. So let's graph this first one. So I've got the square root of 3 minus 3x. Okay, so that's one of them. So that's what the graph of 3 minus 3x is. And the graph of the square root, it's 3 plus the square root. So 3 plus the square root of 3x plus 2. And take a look at that. These are never equal to each other. They have no intersection, right? One is going off in one direction, the other is going in the other direction, right? So it kind of makes sense that there's no solution because the graphs don't intersect. So if one side of the equation, if you graph one side of the equation and you graph the other side of the equation, any intersection would be a solution, right? Because that's where they're equal, where those two sides would be equal. That's what that intersection would mean, right? Now, here there is no intersection, so that means that there is no solution. So, yeah. Okay, so let's talk a little bit about your homework. I don't have a whole lot of homework for you, but I do have a little bit, so I gotta flip this back upside down. And let's see which homework I want you to do today. So I gave you that homework set the other day. I'm just gonna pull that up and I'll tell you which questions I'd like you to work on. Okay, where did it go? Radicals, homework. Okay. So I'd like us to work on some of the equation stuff. So that's a little bit later on. Oh, I wonder if I didn't actually put any of the equation stuff on it. Okay, I may have to include something else later. I can't believe I didn't add any equations in here. That's craziness. Okay, well, here's what I'll get you to do then. So I think we went up to question 8. Let's kind of pick up where we left off. Let's start with question 9. So homework for today will be, so homework is going to be number 9, and let's do A, C, and E. A, C, and E. And I'll write this on the website, so fear not. If you want to write it down, then you can. We'll do 10 and 11. So we'll do number 10, number 11, and let's do 12. I'll do number 12, and we'll do A, and we'll do E, and we'll do K and L. Those are good ones. K and L. And let's do one more question. We'll do number 13. Number 13. So that's your homework for today, and we'll leave it at that. So I'm going to sign out then. Sorry for going over, but yeah, that last question, that was a good question. I made a little mistake there. I think we probably could have done it in a little less time if I hadn't made that mistake. But thanks for catching my mistake. It's important to point those things out. Anyway, yeah, I'm gonna sign out. I'm not gonna yeah, I'm not gonna wait for goodbyes because there's like a 30-second delay. So by the time you hear this, I'll be making my second coffee of the day. So bye bye, and I'll talk to you guys tomorrow. Oh, and please fill out that form. And if you can't fill it out, send me some kind of message, like an email or something like that, and I'll try to get to the bottom of it. But it seems to be working on my computer, so yeah, give it a shot. Okay, bye bye.